Hey, welcome back to the Cable Data Science channel. This is the evening of January the 2nd, 2021. Uh, we're going to continue to work our way through the World Quant University's data lab studio project. Okay, and in your absence, I did create three more of the subs, three more of the steps in the process. And when we get back, I'll be back to you folks in 15 minutes to get this show on the road. All righty now. Okay, as I said, welcome back to the Categorical Data Science Channel. We're continuing to work through the quant, the World Quant University Applied Data Science Lab. Okay, so let's come over here, start up our virtual machine over here. Narrow this down a little bit. Redirecting. I'll just mention they do in fact use Jupyter Lab notebooks. Okay. Okay. Let's come back up here first of all to the first section. Let's just come down here. Let's just take a look. Uh, we haven't actually addressed this thing up here yet. Okay. This is included, but we're not really worried about that. Tabular data, right? So here we have a list again. Now over here, we're dividing this list, so you address it by index position. So we're dividing the first column by the first column, by the second column actually. Okay, so we're dividing housing size by the price. Now we're taking this and we're appending house zero list, appending the this house price per meter squared down here. Now we're creating a dictionary, which is a list of lists, okay, or a nested list, okay. Introduce the basic the basic loop function, which is unfortunately is fairly common in in Python. Okay, this is the current thing we're looking at. So we're basically going to take this and it's going to count the number of entries here, and it's going to increment it. Okay, then let's go the price per meter squared house again, so on, and we're going to append that value onto our table here. Now we're dictionary. Okay, dictionaries are enclosed in curly brackets, and they have matching name, column name, and value pairs. Okay, that's what that looks like. Now calculate the price per square meter for a house, and add that to the under the price per meter square. So we're creating a new column called price per meter squared, and again we're dividing the USD by the by the uh, by the surface area, the size in square meters. Now we're going to perform a row-wise function. So this is one row, 2 rows, 3 rows, 4 rows, 5 rows, and this is the output. Okay, that's okay, but it's not perfect. Let's see. Now we come down here for house, and house is row-wise. So now we're going to divide the column or the pair marked price per meters is calculated by the house USD. So we have the advantage of doing this way of actually using column names. Okay. Again, you can see the final numbers down here. Now we come back houses row wise, and once again we are appending the value for price approximate USD. Okay. And then we're actually calculating the average price per house. and down here again. Now we're defining price and area, column-wise. We create an empty dictionary. Then we say P and A for price and area. In the zip, you have to use zip to combine these two values into a single value. Then you do price per meter squared divide P divided by A. Then you take the price per meter squared and you append it onto our original value up here, okay? Now we get to the fun stuff. Now we get to the fun stuff, which is data frames, all right? Load pandas, create a data frame. Data houses, PD data frame from data to create a data frame for houses. And then we say price approximate USD, mean. You can see how much easier this is. No loops, no tricky stuff, just a simple function tacked onto the end of a data frame, okay? Now you can replace this thing with any built-in function you want. You could do mean, you could do min, you could do max, you could do standard deviation. When you and this is why data frames are so powerful. Okay, so now there's nothing new here. Let's come down here. Mexican data. Again, this we don't worry about that. We import pandas. We come down here and we do the simple read CSV to create 3 data frames. Now we're going to clean the first data frame. As you can see the head here, longitude, latitude, areas per meter. So the first thing we want to do, we want to remove any of the NA rows with NAs. We actually put it down here. So now we're going to convert. Well, see, these things up here are this says price USD, but that's too. But the trouble is, okay. So you can see up here, we're going to deal with the price per meter squared. We got US numbers. We need to use the string function of the string replace function to remove the dollar signs and the commas. Remove the NAs, of course. So we're going to say price USD equals price USD string replace dollar with nothing. Regex eliminates an error. And then we're going to say replace comma again regex. So let's just copy this over here. Because this is actually the function we want to keep track of. So why can't we? So why can't we come back over here? Code. Okay, this is what? This is string replace. Let's replace this. Okay, this just gives us an example of how to use the string replace. Will, of course, come in handy in a moment. So this is going to be drop columns price Mexican. Calculate the price per units and do a round, okay? Okay. So we're calculating the price in dollars. Then we're dropping the Mexican, then we drop the Mexican column and say in place. This means it actually changes the underlying data frame. Now we're back here to US, okay? Clean number 3. Well, we do a couple things. We drop in A. We This is the 2 new columns we want to replace. Notice that this is actually a list. That's how you do 2 things. Then we're going to say df3 longitude latitude, which is the field, and do a spring split on 2 on a comma. Okay. Then expand. Expand actually takes the 2 numbers. Okay, and and expands them out as it says to 2 different columns, but it doesn't actually give them a name. Okay. Let's come over take out this now. Let me come up here, drop in A. All right. I'm back over here. So this is just going to be a cheat sheet where, hey, Mark, how you doing, friend? But you're in module 1 also. I started last night. I did a couple extra things today. I'm just going back through and I'm making some notes about all the commands we've used so far, because I'm sure that these command strings will come in helpful later on. String replace. Let's see, string split. Here's a string split, so we don't actually need this one up here. Yeah, especially when you get to my age, it's good for me because my short-term memory isn't what it used to be. We got an example of drop columns. So are you still on? So you're still in module 1 then? More dropped columns, and then we do a concat. There we go. That should pretty much, yeah, it's okay. I've actually done a little bit with it before. Uh, mainly just some EDA, but there's lots of these commands here, like the string split and replace, that I wasn't familiar with, which helps. Plus, of course, hey, it's free. WorldQuan University is free, so how can we go wrong? And finally, so this takes care of number two. So how many this section have you done 13 yet? Okay. So here's my little cheat sheet. Now, here you go. There's my cheat. There's a link to my cheat sheet. So what do you say we take a look at 13? Now we get to do the fun stuff. Now we get to do the I mean, all this stuff so far, particularly this whole section, these are things we use over and over again. So at some point you want to have to, you at some point you things like the split and the replace and the concat become second nature to us. We won't have to think about it. You look at a data set and say, oh, I have to do a string split here. I'll be back a moment. I'm going to get me something to drink. Okay. Yeah. Now we get to some fun stuff. Exploratory data analysis. Let's just come over here. Here we go. All right. So have you checked out any of the office hour streams yet? The office hour Zoom meetings. I watched a little bit of one earlier today. It was from a couple of days ago, and it's and Yeah, it was just a Zoom meeting, and people joined in from different students joined in from different parts around the world. Uh, yeah, I'm not quite sure. Of course, there's also the forum, right? Yeah. Anyway, so let's start to take a look at three here. Importing matplotlib, pyplot, plt, pandas, of course. Interesting that they use in Plotly Express, which is kind of curious. This I think it just allows you to uh, to display videos online. I'm thinking. So let's come down here. First of all, let's run this. Then let's come over here and let's just run this video here. See what this rascal has to say for us today.
All right, it's time for lesson 3. So before we start, where are we? First, we looked at different ways to look at tabular data using traditional Python structures. Then we did a lot of data cleaning using a very common library for working with tabular data named Pandas. And now that we have clean data, now it's actually time to start exploring it and begin kind of thinking about what sort of research questions we want to ask. So let's talk about the things that we're going to cover in this lesson. Let me pull up the old presentation. Here it is. So in this lesson, we're going to be conducting exploratory data analysis, or EDA, and it pretty much is what it says. We're going to be kind of looking through the data and kind of seeing what's there, seeing what adjustments we need to make, and seeing what we might do with it in terms of our research. So specifically, our goals for this lesson all really have to relate to data. The first thing is we want to conduct our exploratory data analysis, EDA. That's the cool way. That's the cool kids. That's what they say. The second thing we need to do is we need to be thinking about a couple different data types. So first, we're going to be visualizing location data. That is to say, data that represents where in the world something is. The next thing we'll be looking at is categorical data. That is to say, data that falls into discrete categories, like, nationality, United States, Mexico, Canada, etc. And we'll be doing a little bit of data aggregation when it comes to categorical data. So we have location data, categorical data, and then the third is we're going to be looking at numerical data, things like your age, your height, home price, and we'll be looking at ways to put together summary statistics for numerical data. So those are our goals for this particular lesson.
Let's just scroll down here a little bit then. Let's see. After importing, the next step in many data science projects is exploratory data analysis. We get to feel where you get a feel for the data by summarizing its main characteristics using descriptive statistics and data visualizations. A good way to plan your EDA is by looking at each column and ask yourself questions about the data set. Let's come over here. Well, first, did we run our library up here yet? Let's make sure we got this run. Good. Okay. All right.
So with our goals in our noggins here, let's go over to the notebook. And let me just pop myself up here. Hello again, long time no see. And before we dive into this notebook, let's just remember that here in the data folder, in the last lesson, if I open this up and I expand the sidebar here, there is a CSV file which we created in the last lesson. So it's right here, Mexico Real Estate Clean, and that is the CSV file that we're going to be working with. Let me clear that and just make everything normal sized again. There we go. And here in the notebook, we're going to be using 3 libraries. 2 of the libraries are for visualizations. I'll just annotate this here. Visualizations. And that's matplotlib. And then the second one we'll be using for visualizations is called Plotly Express. And note that we are importing them using alias as well, just like we did with pandas. So matplotlib is almost always PLT, and Plotly Express is always PX. And then finally, of course, we have pandas, and that's for our EDA. Beautiful. So now that I have my 3 libraries, I actually need to import them. So I'll hit Shift and Enter to run this cell. Next, I'll scroll down here, and let me zoom in.
Wait, I got hit by a motorcycle while crossing the road the other day. Slightly injured, so I will be working from home for 2 weeks. Lots of laughs. Well, enjoy your rest. Enjoy your recuperation, okay? Glad it wasn't anything too serious.
Let's see. There we go. And what we need to do is we need to take that, there we go. We need to take that file that we created, that Mexico Real Estate Clean, and we need to read it into a data frame. So there are 3 steps in order to do that. The first thing is we're going to be using pandas, so we have to use PD and let the Python interpreter know that we're using pandas. The next thing we need to do is use the read CSV command, since we're going to be reading from a CSV file. And then the third thing is we need to give a string which will point to the location where our CSV file is stored, where it lives. And we know it's inside the data folder. So I start with data and then slash. And then actually, since I'm a little lazy, I'll hit the tab key and we'll see that it gives me an option of the files and I can just select Real Estate Clean. And what I'll do is, before I run this cell, let me create a new cell below it. And then I'll run this cell. And we can see that nothing happened. There's no output, and that's because everything has been read into this data frame. And let's just use a few common exploratory, some EDA commands. So I'll start with shape. And I can see we have our data set. We have around 1,700 observations, 6 features. That makes sense.
There you go. Time to work on your we can do something like this. You can do that. See what else this rascal's up to here.
I'll also look at, let's see here, head, so I can maybe see the first 5 rows of the data frame. And then the last thing I want to do before we dive into looking at location data, numerical data, categorical data, is I want to do df.info. So info. And if I run this cell, like we talked about in a previous lesson, it gives me
There's our data. Now he said do info next, but there's actually more useful things than that, I think. So that looks okay. What about Now this is really helpful. Here, of course, this here doesn't mean anything, but you can see that we have the count's the same. Here's the average of the size of the house in square meters, the average of the price, the standard deviation, the minimum. Of course, again, this doesn't make a difference. Again, the minimum price, or the minimum size, 60 square meters, the minimum price, 25, 75 maximum price, maximum size, 385 square meters. Is that right? That's not a very big house. Okay. Now, if we subtract 25 from 75, that'll give us what's called the interquartile range. Okay, it's sort of a measure of the spread of the data. Okay.
All right, it's time for lesson 3. So before we start, where are we? First, we looked at different ways to look at tabular data using traditional Python structures. Then we did a lot of entries in their index using a very common library for all of the columns. And so let's just think about these columns for 1 second. The first, I think, point that I want to make is that we have latitude and longitude, and that's location data. But in this case, if we look at the data type, we can see that specifically, like the way it's stored, these are stored as floating point numbers. And that is exactly the same way that area and price, which we're calling numerical features, is also stored. So just important to keep in mind that you might have data that represents different things, even though the data type of that column is the same, because, they're both represented with numbers. And then, of course, last but not least, we have property type and state. Those are, for data types, those are objects, and that means that they're string values. And oftentimes you get categorical data stored as strings because you're dealing with the names of the different categories, or sometimes you call them classes too. The names of the categories are classes. So let's keep all of that in mind as we move on to the next video and see how we can represent and analyze these different data types.
Okay. Now, while there are only 2 data types under data from object and float, there are 3 categorical variables: location, categorical, and numeric. Well, the property type would be categorical because there's a limited number of types of structures we handle here, right? A numeric, which is the price and the area, is metered. Location data, here we go. They say that the most important thing in real estate is location. Yes, the old saying, what's the 3 most important things in business? Location, 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 right? And we can see where in Mexico our houses are located by using the lat and lon columns. Since latitude and longitude are based on a coordinate system, a good way to visualize them is to create a scatter plot on top of a map. Oh, this looks interesting. A good tool for this is the scatter map box from the Plotly library. That explains why we got Plotly. Let's come down here then.
The first data type we'll be dealing with is location data. So let's see how we can visualize that and get a sense of where all these properties are located. Let's go here to the notebook, and I'm going to zoom in real quick. There we go. If we look at this chunk of code, let's kind of unpack it little by little. So the first thing we have is px. That's that alias that we used up above. So that's saying use Plotly Express. And then after that, we do scatter mapbox. So that's telling it which, command we want to use. And then inside the parentheses, so we have a parentheses here, we have a parentheses down here. We have, inside these parentheses, we have a bunch of different arguments, some of which I've filled in for you ahead of time, and some of which you need to fill in yourself. Now, what's important to hear, like if this code seems a little bit like Greek right now, don't worry about it. The first thing we need to know is, or the first argument that is really important, is we need to tell scatter mapbox where the data is located. And so we give the name of our data frame, which in this case is df. And then after that, we have two arguments, lat and long. And this is where we need to tell our scatter mapbox, hey, the latitude data is in this particular column. The longitude data is in that particular column.
Interesting enough, I just got a request from a guy named whose name I can't pronounce. An urgent task on BigQuery. You actually showed up there. Let's just try something. You guys are probably working on his Google Data Analytics certification program. Of course, his question, as you can see, is about BigQuery. All right. Well, the thing to begin to keep in mind is BigQuery is just SQL, but it's designed for big data sets. Okay. The syntax is the same. The only thing that's a little more. Uh, oh, so the question is how you create a temp table. Now suppose you want to create a temp table. Uh, yeah, so of course, this is create. Now the question is, can you, uh, so we can refine the thing, okay? I see what it is I did there. I just did a couple queries. So what you do is I enter my initial query, okay? Then I come down to here and I entered my I entered I entered part two of my questions. So both of these two things are related. This was added on to the one above, okay? And I hate to say it, but man, that chat AI, that really is a game changer for solving problems. I mean, hello? Yes, uh-huh. This is Dave. Okay, sure. Hmm. Okay, I'm having trouble understanding English. I'm sorry. So how do you have to divide it? What are you going to divide it on? You got this table. And you want to divide it into temporary tables, right? Uh, can you send me the description of what you're trying to do, like what they gave you? Just attach it to the message. I'll take a look at it then. Mm, I'm not sure. I have to look at see exactly what you want, exactly what they want you to do. Okay, because yeah, mm. In smaller chunks, right? But I don't know how you want to split them up, though. Okay, how many rows are there in a table? Mm. How many rows? Okay, is this for school or for work? Office work, for your job? I really need to see a complete description of what you're trying to do because I'm having trouble with your English. I'm not exactly what you're looking for. Okay, if you could somehow just put something in the message in message and tell me so I can see exactly what they want you to do. Do you have like an email or something like that they sent you so you know what to do? Hang on one second here. Yes, unfortunately, this guy's English isn't real good. So I'm not sure if he's trying to, split it into like there's so many temp table to split into like so many rows or something like that. Or he's talking about trying to split it up into columns rather than rows. I'm not really sure. So I'm trying to get him to send me a to send me something with it, something written about it. So let's see if he calls me back here. I mean, uh, you know, if his objective is to, it sounds like he wants to create an individual temp table for this for chunks of data. I think. Uh, I mean, you could do something like this. All right, where some you know what's interesting? As another guy here, Aaron SQL, he's basically doing the same thing. Okay, some guy from India is trying to do some SQL project of some type, and Aaron is actually doing the work for the guy in the background. The guy's paying him under the table. Okay, and he's actually writing scripts for various things. So, there probably is a market out there someplace for this. But at this point, I'm not really sure I don't know what data the guy's using. I'm not sure if he's trying to split into columns or rows. I'm not sure what he's really trying to do. Here's a question. Would this work? I mean, could we combine? You know, I would have never known this mod function. But I mean, uh, he, we could probably make a living as a consultant just using shared ID to answer to solve tasks for people. So how much should if this guy actually uses my idea? How much should I charge him for this? Oh, hey, you just sent me the email, didn't you? Okay, all right. Oh, okay. Uh, mm, Hmm. Yeah, like I said, that what the guy's trying to do is like way over my head. This I think this probably falls more under a database developer role rather than just like a data analytic role. Because like you, my SQL is really from the data analytic background. How come there's not a way to like? Let's just get back to where we left off, okay?
And in this case, the columns actually have the same name, so we have to put them in strings, but it's going to be the same. So we'll add lat, and then after that, we'll add long. Beyond that, we just have a center point so that our map is going to be centered on Mexico City. We've set the width and height. And then we also have this little hover data, and I'll show you what that does in a second.
Interesting.
But once we have all of that done, we're taking this whole scatter map box and we're
Yeah, that sounds more like a DBA thing to me. Either DBA or database developer, one of the two. You know, those weren't like entry level queries, as you saw. Those weren't entry level queries. Okay.
assigning it to the variable name fig. And we're going to do a little bit of we're just going to update the layout just so that it looks like a kind of like a Google Maps kind of street thing. And then we do finally fig.show, and with parentheses there since it's a method. Now, if I run this cell, I'm going to hit Shift and Enter. And at the same time, I'm also going to zoom out just so you can get a better view. And what we can see is down below this cell, we got to scroll down here, we have this map. And if we hover above the map, let me just make sure that you all can see this. We have a couple different tools. We have tools for zooming in, zooming out, getting particular selections, and you can even reset the view in case there's some sort of, problem. What I'm going to do right here is use the zoom out. By the way, you can also hover over the map and scroll if you have that on your mouse, but I'm going to zoom out here. And we're centered on Mexico City, but the more and more we zoom out, this actually shows us where all the properties in our data set are here in Mexico. And you can see that they're pretty evenly distributed around the country with a considerable concentration in the center of the country and specifically in Mexico City. And I really love this particular layout because it kind of shows us exactly what a scatter plot is. If I pull up my tools here, there we go, we can think here that longitude, or let's see here, latitude is going to be represented on this axis. We'll call that the y-axis. And then along the x-axis, we have longitude. And I think we need a new color for better contrast. There we go. And so all of the latitude coordinates, they go along this way, along this axis. You can think of them as straight lines. And for the longitude, it's the same way. And so basically that gives us a grid, and that grid tells us where we need to locate these particular properties on the map. So that's kind of what a scatter plot is laying things out as a grid and then using those coordinates to place points in a grid. And if you put a map under it, it's even, it's a lot easier to see where everything is. So let's clear that and let's move on to the next task.
Why won't it let me? Okay, let's do this. There. Okay. Now let's come over here. Download. Oh, There we go. Let's just zoom in here a little bit, shall we? Honeywell. Okay, so we got that done, don't we? You still there, Mark? Okay, where did we leave off?
With latitude and longitude, these are kind of continuous variables. They go between 0 and whatever latitude and longitude go to, right? And your property can be placed kind of anywhere along those lines or anywhere in that kind of grid you put together. But when we think about other type of ways of thinking about location, for example, what state is a property in, well, then we're dealing with more categorical data because it's either yes or a no. Your house is either in the state of Oaxaca in Mexico or it's not. It's either in the state of Culhuacan or it's not. So how do we begin thinking about this categorical data? Let's go to the notebook. The column that we're interested in here is the state column. So I'll do DF square brackets and then in quotation marks, I'll put state. And then I'll also do head just to see what's there. And I can see here are 4 states that are in our data set. The Mexico state, Nuevo León, Guerrero twice, and then Yucatan. Now, there are a couple ways to begin thinking about what's going on with our categorical data using a couple different pandas commands. So let's look at them one by one. The first I'm going to look at is NUnique. So this is the number of unique values in this particular column. Remember that we have around 1,700 observations in our data set, but when I look at NUnique, what it's going to tell me is that I only have 30 unique values. So there are 30 states represented in our data set. What are those states, you ask? Well, instead of n unique, I can use just unique, and if I hit Shift and Enter, it will give me the actual values. So everything from the state of Mexico, which we just saw, down to here's Oaxaca and Campeche.
What happened to
values? So there are 30 states represented in our data set. What are those states, you ask? Well, instead of n unique, I can use just unique, and if I hit Shift and Enter, it will give me the actual values. So everything from the state of Mexico, which we just saw, down to here's Oaxaca and Campeche. So now I know what values are in that column. But the next thing I'm really interested in is what are the 10 most prevalent states in our data set? Like, where are most of our properties located? And for that, I'm going to use value counts. So I'll do df state value counts. And let's actually just run this just like it is. And what this is going to give me is series. Notice in this series, like with any series, there are two parts to it. The first part is we have the index, and the index labels for this series are the names of the states. And then we have the values here in this series, and those are the number of properties in each of those states. And actually, if I remove this and we scroll a little bit further down, we can even see that this is a series because right here, we have things that we associate with this series. We have the data type, which we use an int, because all of these values are integers, and then it also gives us the name, which is state. So we can clear that, and we have all of the states that are represented in our data set, but we actually only want the 10 most prevalent ones. So in order to do that, I'm going to take value counts here, and I'm going to chain on head. And head, if I just run it like so, gives me the first 5 values. And if I want all 10, I can put a 10 inside there. And there we go. I can see that the most...
Okay. All right.
most represented states are in the federal district, DF. That's a little bit of a joke, right? Because our data frame is called DF. Anyways, never mind. Inside joke. And we can see that number 10 on the list is San Luis Potosí. So this is how I would see what are the 10 most represented states in our data set.
Okay. Now, aggregate data in series using value counts. So let's try this. First, let's try this. There's 30. There's a list of all the unique states. And finally, there's only there's 5. There's 10. So numerical data, areas, metered square, and the price. So anyway, Mark, my career as a BigQuery consultant is off to a rather rocky start, I would say. Okay. As you saw, I gave him gave him the handle to a good friend of mine, Aaron SQL, who's a big database guy. A lot of SQL Server, I think, in his background, stuff like that. But anyway, it's so anyway. What's the mean? What's the standard deviation? What's the quantiles? Well, there's 2 things we could do here with this, Ender. Use the describe method to print the mean, the standard deviation, quantiles for these 2 things here. All right.
We have a good sense of where our properties are located, but now we want to think a little bit more about like what kind of properties. as they are, how we can describe them. And so for that, we're going to be looking at area and price, and we're going to be looking at some descriptive statistics. And descriptive statistics, if this is the first time you're hearing the term, is basically statistics that you use to describe or summarize the characteristics of a data set. So with that in mind, let's go to the notebook here, and let's look at the two columns that we're interested in. Area squared, a meter squared, and then price in US dollars. I'm going to zoom in here. There we go. And there are, beautiful. There are two columns that I'm interested in, so I don't need to do the entire data frame here. I'm going to get just the two columns. So I'll do double square brackets, and I'll do area m squared. And then after that, in the list here, I'm going to do price USD. And I can do dot head on this if I want to just see what these two columns look like. And here are the first 5 rows. But what I'm really interested in are some of those summary statistics. So instead of head, I'm going to use another really important and valuable tool called describe. So if I hit Shift and Enter, we see a bunch of different things. Let's look through them one by one. The first one is count. That just tells us how many observations are in each column, and they're both 1,736. So not very exciting there. And then next we have the mean or the average. And we can see that our mean property is about 170 square meters, and the mean price is around $115,000. Now that's important information, but equally important is the standard deviation. So we can see kind of what is the spread of those data points. We can see a pretty wide spread when it comes to area, given that the mean is 170 and the spread is 80. And then likewise, we see a pretty big spread with price USD. So we can guess that there's a lot of variation in our data. After that, we have the minimum and the maximum. So here's the minimum and the maximum, and these are the smallest and largest values of those columns. Respectively. And then finally, we have the quartiles. So this tells us what is the 25th percentile in terms of the size of the house and the price of the house. So it means that 25% of the houses in our data set have an area of 101 or less. Same thing with price. And then with the 50th percentile, it's the halfway point. That's sometimes called the median. And then we have the 75th percentile. So 3/4 of our homes are 220 square meters or less.
And if you subtract the 25 from the 75, that gives you what's called the interquartile range, okay? Interquartile range, or IQR.
And then likewise $150,000 or less. So that's what we see when we use DF describe, and this is a great way to get some very important summary statistics like mean, standard deviation, and quartiles when you're working with numerical data.
Let's do this. There they are. Oh, a histogram, also a popular choice. Nobody's really streaming tonight, are they? Wonder where Yuka is. Wonder where Medallion Stallion is. Both of these statistics are supposed to give an idea of the typical value in the column. So why is there a difference? 15 meters square between them. To answer the question, we need to see how house sizes are distributed in our data set. Let's look at the two ways to visualize the distribution. Yes, indeed. A histogram and a box plot. I might add the ever popular histogram.
Numbers are great. Don't get me wrong. I'm a data scientist. I love numbers. But sometimes you can get a lot of information, absorb a lot of information about a data set, not by looking at just numbers, but by visualizing that data. And so let's look at these numerical features in a kind of a different way, not just numbers, but with some pretty pictures. So if I go here to our notebook and I scroll down to task 13.5, the first thing that I'm interested in is creating a histogram of area squared. And let's just keep in mind as we're kind of working.
So this is still okay.
Working through this, that right now we know that the mean of the area is around 170, and we know that there's a pretty big standard deviation around 80. Now, is that like evenly? Is it like a normal distribution? Does it look different? Well, let's visualize to find out. So I'm going to scroll down, and then I'm going to zoom in. And what I'm going to do is I'm going to start by making just the histogram by itself, and then I'm going to add all the different little labels and pieces that make it more interpretable. So we're going to do this bit by bit. So the first thing I'll do is I'll create that histogram, and for that I'm going to use PLT, which remember this is matplotlib that we imported up above. I'll use PLT, and then after that I'll do hist for histogram. And then the only argument that I'm going to provide is the thing I want you to make the histogram of, which in this case is the data frame, and not just the whole data frame, but actually just area squared. There we go, area squared. And then I'm going to hit Shift and Enter, and I get this beautiful histogram. Now, this is already telling us really interesting stuff. For example, if we pull out our pen and take a look here, our mean was somewhere like right around here, and what we thought might be the case is that our data was kind of evenly distributed around that mean. That's actually not the case. That's what we don't have that here. What we have is a skewed distribution. So there are a lot more houses that are smaller, like less than 100 or 150 square meters, and then that average is being pulled up by all of those big houses, like your 350 square meter house, which, hey, if you got it, enjoy it, right? So looking at this visualization, this is good, but there's some things that we need to do to kind of clean it up. So the first thing that I'm going to do, and you can do this when you're working in a notebook, notice how we have all this output here? We actually don't need this output. And so just to suppress it, I'm going to put a semicolon at the end of this line and rerun this cell. Okay, beautiful. Now I don't have that cruft there. The next thing that I need to do, and I'm going to scroll up just so we can see the instructions together, is that I need to add some axes. I need to label the x-axis, I need to label the y-axis, and then I need to give the plot a title. So let's do those things one by one. I'm actually just going to take the label for the x-axis and I'll copy it, and then down here I will type it in. So if you want to add an axis to a plot in matplotlib, you do plt x-axis, x-axis, there it is. Oh no, excuse me, not x-axis, x-label. And then inside the label you do area square meters. Let's just see what that looks like. Beautiful. Now we have a wonderful little label there. And then the next thing we need to do is we need to add our Y label. So that's PLT Y label. And inside there we'll put frequency. Awesome. And then the last thing we'll do is let's just create a title. So I'll copy the title from up above. And then down below, I'll do PLT title. And inside that, I'll put distribution of home sizes. There we go. And before we end this video, I cannot stress how important it is for yourself and for your audience to make sure you label those axes. Because on the one hand, you might come back to this 3 months from now and have no idea what this visualization means. And on the other hand, when you're communicating to an audience, it's really important that they can very quickly see what it is you're trying. So if you want to add an axis to a plot in matplotlib, you do plt x-axis, x-axis, there it is. Oh no.
Let's see if this. I, I don't know. I think this looks a little neater rather than having the data frame and the brackets and stuff like that. So next one. Dot. That should simply be Now let's look at a box plot.
The histogram we just made is super useful in terms of telling us what is the distribution of the house sizes in our data set. And we had that skew, remember? But it's not the only way to visualize the distribution of home prices. So we've looked at histograms. Let's look at another visualization called a box plot, and then you can decide which one's better. So let's go to the notebook here, and this is the histogram we just created. There's one thing that I want you to keep in mind as we're looking at this, which is just look at that we have this kind of skewed
to the right.
This kind of skewed data here. Just keep that kind of shape in your head as we move down to the histogram. Or put that in your memory banks. Next, I'm going to scroll down to where we were, and let's put together the data frame, and let's put together the box plot. So I'm going to start with PLT, because we're using matplotlib again. Instead of hist, I'll put box plot. And then inside, I'm going to use the same series or column that we used before, which is area squared. There's one other argument which I want to add, which is I want this to be a horizontal box plot. And there's this argument for box plots called a vert. And if it's set to true, it'll be a vertical box plot. And I don't want it to be vertical. I want it to be horizontal. So I'm going to set it to false. I'll hit Shift and Enter. Beautiful. This is looking really nice. Now, before we do anything, let's just add those labels. We need to add some labels. Notice here that the y-axis, this y-axis actually doesn't really represent anything at all. So we don't need to worry about that. But let's worry about the other axes in the table, the title as well. So let's do PLTX label, and inside there we will put our good friend price. Oh, excuse me, this isn't price, this is area, right? Area, we'll put this in square meters. Beautiful. And then I'll do PLT title, and even if I scroll up here, I actually have the name of the title. Distribution of home sizes, and I can just paste that right in. Awesome. That looks great. So here we have this this box plot. It looks pretty, but what is it saying? Well, let's pull out the old annotation tool. So what is this telling us? What is this box plot telling us? Let's zoom out for a second and let's scroll up. Remember that when we did df describe, we got these quartiles. We got the 25th percentile, the 50th percentile, which is the median, the 75th percentile, and then we also got the min and the max. Well, those 5 numbers, minimum, 25th percentile, 50th percentile, or median, 75th, and max, those are the ones that are represented in our box plot. So scrolling down and then zooming in, there we go. Let's kind of unpack where everything is. So I have the min and max here. And then inside the box is the 25th percentile. Or rather, the left edge of the box is the 25th percentile. The middle line here, that's the 50th percentile. And then the right edge of the box is the 75th percentile. So what this box here is telling me is that essentially 50% of the data is located between those two bounds. And then, box plots are not just called box plots. Sometimes they're called box and whisker plots. Well, these whiskers, they tell us what the minimums and maximums are. So what we can see here, if we clear these, is we get a shape kind of very similar to what we saw before, in the sense that, our data is pretty skewed here. So again, this is a way to visualize the distribution of our data set, but putting it in kind of a different format, which gives you a really good sense of where the middle 50% of your data is and what the two extremes are. And that's how you make a box plot. We've looked at how size. Now let's do the same thing we just did, but with price. So opening up the notebook here, all right, I'm going to be here in task 7. So what I want to do is I want to create a histogram, but I want that histogram to be for price, not for size. So I'll zoom in here, and let's just kind of get that muscle memory working. We'll kind of do the same code that we did before. We'll do PLT, and we'll do hist, and inside hist we'll put the column we're interested in, which is price US.
Now we can come down here.
USD. And let's do those other axes and stuff, just once and for all, just while we're at it. So I'll do PLTX label, and the X label here is going to be price, and then inside square brackets I'll use USD. Beautiful. And then PLTY label, that's going to continue to be frequency, so no changes there. And last but not least, we need the title, and the title here will be distribution of home prices rather than distribution of, home sizes. And then last but not least, I'll put in that semicolon to suppress the output here. And if I hit Shift and Enter, what I will see is, the distribution of our home prices is actually also, it looks like it's even more skewed. It looks like most of our houses are between $50,000 and $150,000. And the reason why we got that originally high mean is because there are some kind of larger values like 300,000.
Okay, so let's try this. That looks pretty good. It's pretty daggone good shooting there, partner. Pretty daggone good shooting there. Now, we can do a box plot. what this means, of course, is what? Let's come over here and expand this way out. Size or location. I'm going to make a stab, and I'm going to say the actual sum probably has to do with the.
All right, last task. So we made a histogram of home prices. We saw that it had an even bigger skew than the size of the home. Let's see how that bigger skew is represented in a box plot. So let's zoom in. A lot of this code is going to be familiar to you, but again, we're working that muscle memory. So I'll do PLT box plot. I will do DF, and I will do prices USD, because that's the column I'm interested in. And I'll set the vert argument to false because I want this to be horizontal. Then after that, I will set my X label, which is going to be price USD. And then last but not least, I'll do PLT title, which will be distribution of home prices, which I'm just going to grab right here, paste in, and then add that semicolon at the end to suppress the output. And if I hit Shift and Enter and scroll down just a little bit, we can see that we have something that's very similar to what we saw before, in the sense that we have our minimum, we have this maximum, we have this box in the middle showing us the 25th, the 50th, and the 75th percentile. But the other thing that we have here are all of these little, they look kind of like just data points or whatever. Now, what do these data points represent? Well, these are what are called outliers. And the kind of default definition is if that value is more than 3 standard deviations away from your mean, and that's what's being represented here. So what our box plot is telling us is that the skew is so extreme in the case of this data that there are some houses whose price we should consider kind of outliers, not necessarily representative of the houses as a whole, but just kind of like way off the map. Not the location map, but the price map. And being able to locate outliers is really important. On the one hand, it might help you find data points that shouldn't be in your data set to begin with. You know, if you have an outlier for latitude or longitude, that might mean that you have a house in Miami, not in Mexico. Or it might also be an indication that you need to do some sort of transformation to your data so that you can build, like a linear model, like we'll see in the next lesson. For now, we're going to keep the data just as it is, but again, important to realize that one of the great things about this histogram is that it really helps you identify where outliers are. So let's just quickly review what we've done. We took our beautiful clean data set and we began exploring it using EDA, Exploratory Data Analysis. We were able to visualize the location data using a scatter map box plot. We then looked at categorical data, that is the states in which the properties are located, and found the most represented states. And then finally, we did some descriptive statistics with those numerical features, namely area and price. So we used different measurements like mean and standard deviation, and then also that whole idea of quartiles, where you have the 25th, the 50th, and the 75th quartile. And we also saw ways to visualize the distribution of both of those features using a histogram or a box plot. And then finally, we saw a little bit about identifying outliers using a box plot. So we're going to take all of this information into the next lesson, where we're going to see what is it that most determines the price of a property in Mexico. Is it the area? Is it something else? Tune in. You'll see next time, next week, whenever you tune in, next time on this lesson. See you guys later. Bye-bye.
Okay, let's come back up here, see if we can upload our file here. Okay, Mark, I'm gonna go and bring this session to a close here. It's about 10:47 here in Central Ohio. We got a lot done this evening, although unfortunately I wasn't able to help the guy with his BigQuery problem. It was he was really looking for someone like a mid to senior level DBA, I think, or mid to senior level developer, in my opinion. But nonetheless, we're going to bring this all to a close here. 2 hours and 44 minutes, two and a half. That's more than enough for one night.